On July 4, 1997, a tiny spacecraft named Pathfinder made history. It touched down on the surface of Mars. This was a major victory for NASA. It was the first successful Mars rover mission. The world watched with bated breath. Everyone was eager to see what Pathfinder would find. Pathfinder was different from previous missions. It wasn't just an orbiter, it carried a rover. This rover was named Sojourner. Sojourner was a small, six-wheeled robot. It was designed to explore the Martian surface. This mission marked a new era in space exploration. The successful landing sparked excitement. It reignited our fascination with the Red Planet. Pathfinder was more than just a mission. It was a symbol of human ingenuity and our insatiable thirst for knowledge. It showed that we could explore other planets with robots. Pathfinder paved the way for future missions. It proved that we could land rovers on Mars. It also demonstrated that these rovers could collect valuable data. This data would help us understand Mars better. The Mars Pathfinder mission was developed under NASA's Faster, Better, Cheaper program. This program aimed to develop and launch missions more efficiently. It also aimed to reduce costs. Pathfinder was a prime example of this approach. The mission had three primary goals. The first was to demonstrate a low-cost method for delivering instruments to Mars. The second was to deploy the Sojourner rover. This rover would explore the Martian surface. The third goal was to conduct scientific investigations. These investigations would focus on the geology and climate of Mars. Pathfinder was equipped with innovative technology. It had a unique airbag landing system. This system would cushion the impact upon landing. This was the first time such a system would be used on Mars. The mission also featured a robust communication system. This system would allow for direct communication with Earth. The development of Pathfinder was a race against time. Engineers and scientists worked tirelessly to overcome technical challenges. They had to work within a tight budget. Despite these hurdles, the team persevered. They delivered a spacecraft that was ready to embark on its historic journey. On December 4, 1996, Pathfinder embarked on its journey to Mars. It was launched atop a Delta II rocket from Cape Canaveral Air Force Station in Florida. The spacecraft began its 7-month, 309-million-mile journey. The journey was long and arduous. Pathfinder had to withstand the harsh conditions of space. These included extreme temperatures, radiation, and the vacuum. The spacecraft's systems were constantly monitored by the mission control team back on Earth. They made sure everything was functioning properly. During the journey, Pathfinder performed several trajectory correction maneuvers. These maneuvers ensured that the spacecraft was on course for its Mars encounter. The team at NASA's Jet Propulsion Laboratory worked tirelessly. They tracked the spacecraft's progress and made necessary adjustments. As Pathfinder approached Mars, the excitement grew. The mission team prepared for the critical landing sequence. They knew that success depended on a flawless execution of the entry, descent, and landing procedures. They had meticulously planned and rehearsed every step. Section 4, Touchdown, an innovative landing on Mars. On July 4, 1997, after its long journey, Pathfinder reached Mars. The spacecraft entered the Martian atmosphere at a speed of 16,000 miles per hour, or 25,750 kilometers per hour. The heat shield protected it from the intense heat generated during atmospheric entry. Pathfinder deployed its parachute. This slowed its descent further. Then, in a groundbreaking maneuver, the spacecraft inflated a system of airbags. These airbags surrounded the lander like a protective cocoon. They would cushion the impact with the Martian surface. The airbag-encased lander bounced several times on the surface. It finally came to a stop in a region called Ares Vallis. This landing site had been carefully selected. It was chosen for its smooth terrain and scientific potential. This innovative landing system was a resounding success. It demonstrated a new way to safely land on Mars. The Pathfinder mission marked the first time that airbags had been used to land a spacecraft on another planet. This innovative approach proved to be highly effective. It paved the way for future missions to use similar landing systems. The successful touchdown of Pathfinder was a testament to the ingenuity and skill of the NASA engineers. Section 5. Mars in View, First Images and Discoveries. Minutes after landing, Pathfinder began transmitting data back to Earth. The first images arrived, revealing a rocky, dusty landscape bathed in the pale light of the Martian morning. The world was captivated by these first glimpses of the Martian surface. The images showed that Pathfinder had landed in a region littered with rocks of various shapes and sizes. Some of these rocks appeared to be rounded, suggesting the presence of ancient water flows. This discovery fueled excitement among scientists. It hinted at the possibility of a once warmer and wetter Mars. Pathfinder also began collecting data on the Martian weather. It measured temperature, pressure, and wind speed. This data provided valuable insights into the dynamics of the Martian atmosphere. It helped scientists understand the climate patterns on the red planet. The initial observations from Pathfinder provided a wealth of information about Mars. They confirmed that the planet was once much different than the cold, dry desert it is today. The data also helped scientists refine their models of the Martian environment. Section 6. Sojourner, the little rover that could. Once Pathfinder had settled on the Martian surface, it deployed its most celebrated passenger, the Sojourner rover. This small, six-wheeled robot was about the size of a microwave oven. It was designed to explore the area around the lander and analyze rocks. Sojourner was equipped with a camera and several scientific instruments. It could move at a snail's pace, traveling up to 1 meter per minute. It used its instruments to study the composition of Martian rocks and soil. This data would help scientists understand the geological history of the landing site. The rover was controlled remotely from Earth, with commands sent via Pathfinder. Due to the distance between Earth and Mars, there was a significant delay in communication. This made controlling Sojourner a challenging task, requiring careful planning and execution. Despite its small size and limited range, Sojourner made some significant discoveries. It found evidence of different types of rocks, suggesting a diverse geological past. The rover's analysis of these rocks provided clues about the presence of water on ancient Mars. Section 7. Pathfinder's Enduring Legacy, Inspiring Future Exploration. The Mars Pathfinder mission was a resounding success. It far exceeded its initial goals, operating for nearly 3 months and returning a wealth of scientific data. Though Sojourner's journey was short, it covered over 100 meters, analyzing rocks and capturing stunning images of the Martian landscape. Pathfinder's success had a profound impact on future Mars exploration. It demonstrated that rovers could be effectively used to explore the Martian surface. The mission also paved the way for more ambitious rover missions, such as Spirit, Opportunity, and Curiosity. The innovative airbag landing system used by Pathfinder became a model for future missions. It proved to be a reliable and cost-effective method for landing spacecraft on Mars. This technology was later employed in the successful landings of the Spirit and Opportunity rovers. More importantly, Pathfinder reignited public interest in Mars exploration. The mission's captivating images and scientific discoveries inspired a new generation of scientists, engineers, and space enthusiasts. It showed the world that exploring other planets was not just a dream, but a tangible reality.